Hi, I was already introduced. One more thing that you need to know about me is that I'm obsessed with cats, and so I cannot give any presentations without cat pictures, so you might see some hidden cats or not so hidden cats on my presentation. So very quickly to set the stage, talking about fragility in the context of AI and data, I also want to mention this map or this slide is about 10 years old, but I decided to use it again because unfortunately not very much has changed. So this is Africa and parts of the Middle East. One click shows us conflict incidents from about 8 to 10 years ago. So these brown dots are actual geotagged conflict hotspots, ACLED data, which Jay also mentioned before. And then more clicks shows us displacement camps, in this case refugees and IDPs from these conflict incidents, which is already quite interesting because it shows us that most of these displaced people are not in Berlin, Vienna or Stockholm, but they're in the immediate neighborhood of the conflict incidents. Another click shows us food security levels from, 7, 8 years ago. And again, unfortunately, not many things have changed. So the point of showing this is to indicate that there is a association, correlation, I would strongly argue causality between where the conflicts are happening in these fragile states, where the displaced people are, and where things are not going well in terms of socioeconomic development. So this is an indicator or a proxy for socioeconomic underdevelopment. And then 4 more clicks shows us that about 8 years ago, there were several famines in these areas where the conflict hotspots were the highest. So why am I showing you this? I'm showing you this to make the case that on the one hand, those are the areas where development interventions are most urgently needed in order to change or break the vicious cycle between underdevelopment, no opportunities, conflict leading to even less opportunities, etc. But at the same time, the big problem here is that in these areas is extremely limited access, which makes it very hard to implement projects and which also makes it very hard to get data out of these areas. And we need data to, on the one hand, plan and supervise projects, and on the other hand, I'm clicking in the wrong direction, sorry. On the other hand, feed into AI. Given that this conference is about AI for technology, obviously I wanted to have a clear hint. The point is, in fragile states, it is extremely difficult in the current moment to use AI effectively in the development context for the simple reason that we don't have enough primary data. We have a huge garbage in, garbage out problem. And as you all know, AI is working with secondary data and perpetuating the already existing secondary data. And because of this, we figured, well, in order to make a difference for AI, but also for development itself, we need to invest in better primary data. And this is what my program is about. That was already mentioned in the introduction, and Jay hinted to it. So I'm the leader of the Geo-Enabling Initiative for Monitoring and Supervision, and I want to talk a little bit about this, what it does and how it relates to development. First of all, the acronym is GEMS. I briefly considered calling it Geo-Enabling for Remote Monitoring, but the acronym GERM was somewhat less appealing than GEMS, even though I think it's easy to remember. And so what GEMS does is building capacity with government agencies, line ministries, project teams, and basically anyone you like, anyone on the ground, to set up customized systems based on very simple technology to collect primary data that they need for their specific purposes, for their project, for their infrastructure, for tracking of service delivery, and of course, eventually for feeding into AI. Here are my cats. Why am I showing you my cats? Well, 2 reasons. Number 1, my cats are wonderful and everybody should see my cats. Number 2, oh, you have also a cat? Okay. Number 2, to make the case that GEMS is about more transparency and accuracy for better development decisions. Now again, why the cats? Well, I have glasses because I'm short-sighted, and if I don't I speak loudly now because I'm walking away from the mic. If I don't put on my glasses, I see 4 cats. But if I put on my glasses or I go a little bit close, oh, okay, that's smart. Sorry, I'm not so good with the technology as it seems. So if I go a little bit closer, or I put on my glasses, I realize, no, it's not 4 cats, it's only 2 cats. The other 2 are fake. So the point is that GEMS tries to give you, the government, the project teams, the donors, and everybody involved glasses to be able to see what is happening on the ground. Or, as we say, to get eyes on the ground where you cannot always have boots on the ground. Now, the truth is, the picture with the cats existed already before, and then I decided to build a story around it so I can show my cats, but I hope the story makes sense. So, in this context, GEMS, or the core of GEMS, as already mentioned, is to teach project teams and local counterparts how they set up their own digital monitoring systems, own digital data collection systems, which can influence development decisions in terms of planning, in terms of project supervision, in terms of impact evaluation, etc. Works very simply. Top right, the picture, this is a typical GEMS training. It's actually a real picture from a training in Nigeria. Based on this training, the counterparts learn how to program digital questionnaires, go into the field with them, and collect them with simple smartphones. And then eventually the data feeds into these interactive monitoring systems that shows you who is doing what, where, and when. And the idea is really to focus on very simple tools and systems so that they can be owned by the clients, by the project teams, by the governments on the ground, no matter how low or high the capacity may be. So what we are trying to reach with this is, as already mentioned, getting eyes on the ground where you cannot always have boots on the ground. In this case, as an example, it's moving into northeast Nigeria. These red flames are actual geotech conflict incidents. That's ACLED data. And in the midst of all of this is a project, or several projects. And what you see here are the exact geotech location of this water project. A picture, a couple of indicators, and obviously other things that you can collect is an audio recording of an interview, a video recording, scanning of a barcode of some item or whatever that has been delivered. So using GEMS in this context makes it possible to remotely supervise the project without having to be there, because you know the exact location. You have metadata with the time and the date stamp and when this was taken. You have pictures from the field, but it also generates extremely valuable primary data about these projects, which eventually can feed into AI and help us draw better conclusions. Now, when talking about using technology for getting better insights, I summarize this as the 3 sciences. The first one is the rocket science. What I mean with rocket science is remote sensing through satellite imagery. Why I call that rocket science? Well, 2 reasons. Number 1, they're most literally launched by rockets. Number 2, because in English you call something rocket science that is complicated, complex, not everybody can do it, not everybody understands it. And that's a bit the problem with satellite imagery. It can be very powerful for certain kinds of projects, large-scale infrastructure or construction, but when there's cloud cover, you see nothing. Radar works, but visual data doesn't work. It doesn't speak with people. You can't look inside a building. And most importantly, local counterparts may have issues actually using it because you need good computers, you need, in most cases, high-resolution imagery, which is expensive, and you need the respective skills to work with it. So the core of GEMS is actually not about the rocket science, and here's my punchline, it's about the, wait, how do I do this? It's about the pocket science. I'm pulling my phone out of my pocket. So what we are trying to do is not focus on disruptive technology, high-tech, something very new or fancy like AI, but actually going back 15 years in time to help build the foundations to make AI work, getting good structured geotech primary data. So the core of GEMS is teaching local counterparts how they collect good geotech data in the field with simple tools, with the pocket science. And I call this pocket science, again, for 2 reasons. Number 1, because you carry the smartphones around in your pocket, and even the project teams in Africa, they all have smartphones. And number 2, to indicate that it's something simple, something close to you, something that is not complicated. It's not rocket science. Now, I had 2 orchids McKinsey says you always need 3 bullet points to make a case, so I needed another socket. So therefore, there's also a socket science. A socket is something that you plug into to get electricity or data out of it. What I mean is building a geospatial digital ecosystem with primary data, with satellite imagery, so the pocket science and the rocket science, and then plugging into other data sets and plug AI into all of it to better analyze what is actually happening on the ground and draw conclusions about it. So, as a summary, GEMS is trying to focus on the pocket science, but bring everything together with the rocket science and the socket science. Now, how do we do this? GEMS is a big team by now, and I do want to highlight, without Korea, GEMS wouldn't exist, because we founded it based on a grant from the Korean Trust Fund, and through this we built up a team. And right now we have 45 team members that are based all around the world that are supporting projects, and they currently have a foot in about 500 projects, which they're continuously supporting to collect better structured data in the field. And I'm showing you this map inter alia because if you work for another development organization, like ADB, like KOICA or whatever it is, we would be delighted to work with you and support your projects with our team members that are already on the ground. Now, how do we do this? Because GEMS is not a tool, it's a program, and we did not develop a single tool. We decided to use tools that are already out there and just help connect the dots to them and teach people in the better use in the development context. So there's a couple of tools that we're working with. The go-to entry tool is Kobo Toolbox. Can I ask for a raise of hands? Who of you knows Kobo Toolbox? Three people-ish. Okay. Kobo Toolbox is a very simple, cost-free, open-source tool that helps you set up your own data collection and analysis system. It's so simple that you can learn it in 3 days, everything you need, and this is the core of our business. And it's cost-free, so they even give you free server space up to a certain amount. And then other tools that we're working with for sophisticated analysis are Power BI, for dashboards, are GIS, different kinds of GIS for analysis. So again, what is the core of GEMS? The core of GEMS is systematically building capacity with local stakeholders in the creation of customized digital data collection and analysis systems so they can better monitor their projects, but also they collect better structured and geotech primary data, which can feed into AI and any kind of analytical functions. Here's my cat again. GEMS overall actually has 3 pillars. I mean, let's say 2, the other one is a bit complicated. The first one is really, we teach counterparts to set up digital systems that work for them. We don't tell them what data to collect, because every project is different, and I'm not an expert on education, health, agriculture, and water. Neither am I an expert on India, Bolivia, and Azerbaijan, but the clients are. So what we do is we help them to do or to translate the work that they're already doing, usually with pen and paper, into a digital system. So we digitize their monitoring and data collection workflows. And then the use cases are, there are hundreds or thousands of them. Those are just examples basically along the project cycle, from project planning and baseline code collection over real-time tracking of projects and service delivery down to citizen engagement. And you can look at this on a project-specific side and on a big picture side. So how do we do this? Well, the core of GEMS is delivering these 3 days on-the-ground capacity building training with local stakeholders, where we teach them everything they need to set up and run their own system. So it's not just about data collection, it's about creation of accounts, privacy and data protection, building a good data architecture, then actually collecting the data and analyzing the data in the system. And the system is so simple that even if you have never worked with anything like this, you have very low local capacity, after the 3 days it really works. I personally have trained 5,000–6,000 people in about 60 countries. And at the beginning, everybody is always skeptical, like, oh no, we have never done this, we can barely use Excel. But after 3 days, they really run with it. It works. And then you have these wonderful hundreds or thousands of use cases around the world. And the ones that we like most are actually the ones on the bottom right in green, meaning we might train them for a World Bank funded project, but then they take it forward into their ministry, into their government, and use it for whatever they need. So it has nothing to do with the World Bank anymore. It just helps getting better and more sustainable data and monitoring systems in the government. I'm almost done. Here is the second pillar of GEMS. So as mentioned, the first one is capacity building so clients can use it for their own needs. The second one relates to what Jay mentioned. We don't know where our projects are, at least not precisely. We might know in which districts they're implemented, but if the district has 3 million inhabitants and is as big as Pennsylvania, then that doesn't really help us with supervision. So the second pillar is systematically geotagging the exact locations of World Bank funded projects, but also other partners. And so far, worldwide, we have about 600,000 project sites mapped with locations, indicators, and photos. And just in Africa, it's actually by now over 400,000. That is also something for if other organizations are interested in learning this and doing this jointly, where we are happy to cooperate. The timer has stopped. Okay, I'm done in a few seconds. Final point, as mentioned, GEMS is based on the World Bank, but we want to create a global public good, and we invite everybody to work with us, to participate in our trainings free of charge. We are no business, we are not making money in this, and to jointly launch these data collection systems so we can better jointly supervise projects. If you want to learn more about GEMS and do a little online e-learning course, you can type in Google OLC course World Bank GEMS, or if you're very fast, you can maybe take a picture or write down this URL, or just look for OLC course 43971. It also has pictures of my cats, just saying. Thank you.
Thank you, Bernhard.